Hello, how is everyone doing? Hope all is well with everybody. I just wanted to go and first of all, I'm sorry for the people that could not get into the Zoom meeting. My apologies for that. Okay, so I just wanted to go over a few problems dealing with what we talked about yesterday. So remember, the main thing we talked about in class was about the binomial experiment, actually. The binomial distribution. Just remember from last week what we actually talked about here. What do we have, right? So there must be a fixed number of trials, right? Each trial can have only two outcomes. You have a positive outcome or a negative outcome, or some people call it just basically a success, or you have a failure, right? The outcomes of each trial must be independent from each other, okay? So the outcome of one, outcome of one can't affect the outcome of another one, okay? So like, for example, you can't have something like cards without replacement or anything like that, okay? The probability of success must remain the same for each trial, okay? So the probability of success has to be the same for each trial. So it must be constant. This, remember, was the actual formula right here, all right? The probability in a binomial experiment, the probability of exactly x successes in n trials is, right here, for x successes right here, we say ncx times the probability of success to the x power times the probability of failure to the n minus x. That means the total number of trials minus the x, right? X is how many successes you want to find. All right, but of course I told you that we can use our calculator, right? This slide explains that, right, which I've given to you. So what I did want to actually talk about, though, is we don't have to always use Binomial Pdf, and I'll tell you why it wouldn't be good to always use it. Let's look at an example right here. All right, so it says right here, and let me add right here actually another slide just for workspace. There we go. So, okay. That's great. Like in problem A, right here, it says right here. Let's read the problem first of all. It's reported that 5% of Americans are afraid of being alone in a house at night. If a random sample of 20 Americans selected, find their probabilities by using the binomial table, or actually we're just going to use the TI-84 calculator, okay? So for A, yes, PDF would be great, right? Because we're going to, and remember on the TI-84 is what we're doing right here. Binomial PDF is like when they say exactly, okay? There's basically this one outcome you're trying to find to get. There are exactly 5 people in the sample who are afraid of being alone at night. All right, so what do we have to figure out right here? Well, first of all, it is binomial, right? We have, if you go back to our previous slides right here and look right here, what would we talk about? Why is it specifically binomial? All right, fixed number of trials, yes. Each trial can only have 2 outcomes, yes. The outcome of each trial is independent. Probability of success must remain the same for each trial, right? So we're good right there. Okay, so let's take a look. Right here, it looks like we have a total number of 20 trials, so n will equal 20 right here. The probability of each is constant right here. It's 5% of Americans, so my probability of success is constant. That's 0.05. All right, all good right there. And A says there are exactly 5 people in the sample who are afraid of being alone at night. So my X, which is my number of successes that I want, it's only one single number. So in that case, if it's only one single number, that's when we know, ding, 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 we need to use Binomial PDF, okay? So what we will do right here is we're going to say Binomial PDF in the TI-84 calculator, okay? I'll just set this up and I'll show you. All right, and first you enter for Binomial PDF, first you're going to enter the number of trials. So n is my number of trials right here. We have 20, okay? Then it's going to ask for what is the probability here. P is the probability of success, right? And that's 0.05. X is going to be basically, in this case for PDF, that's the number of successes that you want, right? And so in this case, they said that we want 5 successes. So we'll say right here, X equals 5, okay? So let's go ahead and do that. Sorry, hang on. Let's see here. Sorry for this wait. It takes a second. There we go. Okay, great. All right, so we're going to go and say second distribution. Okay, I'm just going to write that down for people. We're going to say second, and I'm going to say distribution is what we go and select. Remember, the distribution is in the blue. Okay, you see right there, blue. Okay, and then we go down to letter A after that. Okay, that's Binomial PDF. If you want to, you can just go like up like this. It's easier to get to. There we go, Binomial PDF. All right, and then it's easy from there. You just enter in what you already have. It always goes in the form of NPX. Okay, is how it's going to go from there. All right, so let's go ahead and do it. So N right here, it's 20 trials. Probably a success is 0.05. And the X, the number of successes that I want, is 5. And I press paste, and I get my answer, 0.002. Very small probability right here that there's exactly 5. But that is my answer. All right, so there's a 0.002 probability of exactly 5 people in the sample out of 20 who are afraid of being alone at night. Okay? Now, let's take a look at B. That's a little different. There are at most 3 people, okay, in the sample of 20 who are afraid of being alone at night. Okay, let me rewrite that right here. All right, so there's at most 3 people out of 20 who are afraid of being alone at night. Sorry about that, hang on. Three people of the 20 afraid of being alone at night. Okay, I'm just going to keep that as afraid of being alone. Fine. All right, so right here, what does that mean, right? So there's 20 in the sample, so N still equals 20. The probability of just in general right here is basically the same from our previous example right here, 5%, right? 5% of Americans. So my probability of success, I know that sounds weird, success is afraid, but in the context of this problem, that's what it is. Probability of success is 0.05. Now the difference right here, what does that mean at most 3? Okay, let's go and define that. At most 3. Well, we have 20 people right here. So that would mean 0 people. It could mean that X equals 1 person. It could mean that X equals 2 people. It could mean that X equals 3 people, right? And if you look at that like in the context of like a number line, right? Let's think about that, right? So we have all the way up at 20, all right? We could have 0, we could have 1, we could have 2, we could have 3 right here. Now everything else, right? If X equals 4, X equals 5, blah, 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 blah. We do not want this here, but we do definitely want this. This is good right here. This is what we indeed want right there, okay? We indeed want 3, 2, 1, and 0. Okay, now, how could you do this? You could do binomial PDF, you know, N's 20, P is 0.05, X equals 0, plus binomial PDF, N 20, P is 0.05, X equals 1, etc., etc., okay, up to 2, up to 3. But a better way of doing this is something called binomial CDF, right? And this right here, we use CDF right here when we're doing a problem that's less than or equal to, okay? So in this case right here, the easiest way to do it is we would actually say right here, so let me get rid of this real quick. We would actually go and just say right here, binomial Cdf, okay? My n is still going to equal 20. My p is still going to equal 0.05. But remember, if you look in context of this number line, sorry about that terrible line right there, my fault. There we go, it's better. Okay, right here, we were talking specifically about 3, 2, 1, and 0 was the good here. The good was 3, 2, 1, and 0. So we're going to say right here, x equals 3 because CDF means less than or equal to. Okay? So that's what we're going to actually put in here. All right? So we'll go ahead and say second distribution. Go here. We go to B, right? There we go. We're going to go trials is 20. P is 0.05 still. But here the x value is going to be 3 because it was less than or equal to 3. Okay? Is what we're talking about right here. Awesome. And so we're going to go press enter. And this is going to give me a very large value, 0.98, whatever. I missed the last digit there. 0.984, right? Okay. So the probability of there being at most 3 people of the 20, 3 people of the 20 in the sample who are afraid of being alone at night is 0.984. A huge, huge probability. Most of the sample, I mean, not most of the sample, sorry. It's a very large probability. Okay. All right, let's look at the next one. C. What's the probability that there are 3 people in the sample, at least 3 people in the sample who are afraid of being alone at night? All right, so let's figure this one out. Okay, so now we're trying to figure out at least 3 people. Okay, let's do it. So now we want to find the probability that is going to be at least 3 people. Okay, so that means that probability that x is going to be greater than or equal to 3. Okay, this is a little different. The last one was less than or equal to. Now this is greater than or equal to. So how do we do this? Now sadly, on the calculator, we only have a button for less than or equal to. Remember, I said that binomial CDF is less than or equal to. Okay? Let's figure it out. It always helps if we draw a number line. It doesn't have to be perfect, but just to figure out, we want right here greater than or equal to. All right, so we have 0, 1, 2, 3, 4, 5, 6, blah, 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 all the way up to 20, right? Okay, so right here, what do we want? All right, well, the yellow right here is the good in this case right here. So we do want all this stuff right here. All right, let's call this the good. All right, and let's call this part right here the bad. This is what we don't want right here, okay? We do want 3, 4, 5, 6, 7, 8, 9, 10. Now, if we did PDF, this would take forever, right? Binomial PDF 3, Binomial PDF 4, etc. So it would only make sense to do Binomial CDF right here. All right, so how would I do this, though? Well, let's think here. All right, well, what we can do, remember, is we can say 1 minus, and that will get rid of the bad. Okay, so let's see here. Let's go and eliminate the bad by saying 1 minus. We're going to say 1 minus binomial CDF. Okay, and now let's get rid of everything that is not greater than or equal to 3. Well, what would that be? That would be 2, 1, and 0. So we would say 1 minus binomial CDF, all right, n is still equal to 20. P is still equal to 0.05. x is going to be equal to 2 because we want to get rid of this 2, we want to get rid of this 1, and we want to get rid of this 0. And that's 1 minus will give me the rest of the distribution, which is what we want, the good, okay? So all you would just say right here, you could do it in 1 step if you want, or 2 steps. It doesn't matter. Just remember to do 1 minus. I'm going to do it in 1 step just to show you. I'll say 1 minus. All right, I say second distribution. And I go up here. I'm going to say binomial CDF right here. N is 20, P is 0.05, and the X value, I'm changing that to 2 right here, right? Let's enter. All right, so I have 1 minus, so we're good. So our answer is 0.075, right? So the probability of there being at least 3 people who are afraid to be alone at night from the sample of 20 is 0.075, okay? Relatively small probability, only about 7%, okay? Is the probability. All right, so the first one, A, exactly 5, very small, 0.002. The second one, at most 3 people. All right, that was very large, right? That was what, where was that? 0.984, right? And the third one right here was what? It was this one right here. This was part C. That was a small probability, also 0.05. That was at least 3, right? From the sample of 20. Now, why is the first and third one so small? Well, if you think about it, there was only a 5% chance that someone could be afraid of being alone at night, right? 5% is very small. So, you know, the reason that this one right here, part B, at most 3 people, that's a small amount out of 20, right? So that's one that's going to have the largest probability, okay? Because that would make the most sense right here. All the ones at least 3, well, that could be 3, 4, 5, 6, 7. That could be a large, so that's going to be a smaller probability there. All right, if you take a look right there, those are all of our answers right there that we actually got right here, 0.002, 0.984, and 0.0076, right? That's what we got right here. Yep. And so that's all good right there. And yeah, you see it's a little off, 0.075. They got 0.076. If it's only, that's a, you know, that's only a 1/1000th decimal point off. So it's very close. All right. I think the other ones were, they did it just a slightly different method. So they got, but it's basically the same answer. Okay. All right. So just remember that, just to sum it all up, guys, right here, I just made a slide summing this all up. And let's see here. When finding the probability of a binomial random variable using the TI-84, remember, if the problem asks for the probability of an exact amount, that means exactly 1, exactly 2, then use Binomial Pdf. If it asks for the probability that is less than or equal to, use Binomial Cdf. And if the problem asks for the probability that is greater than or equal to, at least 1, at least 2, etc., use 1 minus Binomial Cdf, okay? So you're all good there. All right, hope that clears some stuff up. That was most of the lesson. If you have more questions, please ask. Okay, see you later. Hope all is well.